Hi guys, welcome to this Easy Maths video, and today we're looking at the AS Edexcel Pure Maths paper from May 2018. The time allowed for this paper is 2 hours. It's a calculator paper which is made up of 15 questions totaling 100 marks. It's important to note that answers should be given to 3 significant figures unless stated otherwise. Question 1 says find the integral of 2/3 x cubed minus 6 root x plus 1 with respect to x, giving your answer in its simplest form. Okay, so the first thing I'm going to do is I'm going to rewrite this integral. So we can write it as 2/3 x cubed minus 6 x to the power of a half plus 1, all with respect to x. Now, to integrate a function, we add 1 to the power and we divide by the new power. So 2/3 x cubed is going to become 2/3 multiplied by a quarter, all multiplied by x to the power 4, because we add 1 to 3, which is 4, divide that by 4, so that's the same as multiplying by a quarter. And minus 6x to the power of a half is going to become minus 6 multiplied by 2/3 multiplied by x to the power of 3 over 2. And then plus 1 becomes plus x. And then remember, because we've got an indefinite integral, we need to add this constant, this plus c, at the end. So if we simplify this, we get 2/3 times a quarter, which is 2 over 12, which is the same as a sixth. So 6 of x to the power of 4. And minus 6 times 2/3, which is minus 4 x to the power of 3 over 2, and plus x, and plus c. And that is our final answer. Question 2, the first part says show that x squared minus 8x plus 17 is greater than 0 for all values of x. Okay, so to do this question, we can rewrite this quadratic in its completed square form. So we're going to half the coefficient of x, so we get x minus 4 all squared. Then we can square the 4, which is 16, subtract that, and then add the 17. Okay, and that's going to be greater than 0. So now this simplifies to x minus 4 all squared plus 1 is greater than 0. Now what you should be able to see is if I substitute any x value, whether it's positive or negative, into this function, my function is always going to return a positive value. It's always going to return a value that's greater than 0. So I can say when a value is substituted into the function, a value greater than 0 is always returned. Now, the second part of the question says, if I add 3 to a number and square the sum, the result is greater than the square of the original number. State giving a reason if the above statement is always true, sometimes true, or never true. So what we're saying is if I have a number, let's call it x, and I add 3 to that result and I square it, it's going to be greater than x squared. Well, let's test some values to see whether this is true. Let's say x is equal to 1. Let's see what happens. So we're going to get 1 plus 3 squared, which equals 4 squared, which is equal to 16. And then here we're just going to have 1 squared, which is 1. So 16 is obviously greater than 1. So we know it's true for that case. But let's see what happens if we use a different number. Let's say we use a negative number that's much more smaller than 1. Let's say x is equal to minus 2. Well, we have minus 2. What's going to happen is we'll do minus 2 plus 3 all squared. Now that's going to leave me with 1 squared, which is 1. And then on the right hand side, I'm going to have minus 2 squared which is 4. Well, here I would be saying that 1 is greater than 4. Well, we know that's not true. Now, what can we do? Well, we can actually solve this inequality. So what we could say is we could expand this. We get x plus 3 all multiplied by x plus 3, which is greater than x squared. And if we expand this bracket, we're going to get x squared plus 3x plus 3x plus 9 is greater than x squared. Well, if we simplify this, we're going to get x squared plus 6x plus 9 is greater than x squared. And then subtract x squared from both sides, we're going to get 6x plus 9 is greater than 0. Subtract 9 from both sides, we get 6x is greater than minus 9. And then divide both sides by 6, you get x is greater than minus 3 over 2. So what that means is any values that we substitute into this inequality that are greater than minus 3 over 2, the result is going to be true. So we can include this in our answers. So if we say the statement is sometimes true, this is when x is greater than minus 3 over 2. Then we can say when x is smaller than this value, the result is false. Question 3 says, given that the point A has a position vector of 4i minus 5j and the point B has position vector minus 5i minus 2j, part A says find the vector AB. So we know the position vector A is 4 minus 5 and the position vector B is minus 5 minus 2. So the vector A to B is going to be the difference between the position vector B and the position vector of A. So if we simplify this, we get minus 9 and then minus 2 minus minus 5 is going to be 3. And now what I'm going to do is I can write that in IJ notation. So that's going to be minus 9i plus 3j. Part B says find the magnitude of the vector AB, give your answer as a simplified third. So we know that the vector AB is minus 9i plus 3j. So we can draw this vector. So it's going to be minus 9 units to the left, and we could do 3 units going up. So if we say that's minus 9, that's 3. These are going to be perpendicular to each other. The direction of the I and j components are perpendicular to each other. So what that means is the length of this vector, so A to B, we can just find out using Pythagoras' theorem. So it's going to be the square root of minus 9 squared plus 3 squared. So therefore the magnitude of the vector A to B, if we work that out on our calculator, we get 3 root 10 as a simplified third. Question 4 says the line L1 has equation 4y minus 3x equals 10. The line L2 passes through the points 5, minus 1 and minus 1, 8. Determine, giving full reasons for your answer, whether lines L1 and L2 are parallel, perpendicular or neither. So first thing we can do is we can look at the equation for the line L1 and we can rewrite 4y minus 3x equals 10 into the general equation of a straight line, which is y equals mx plus c, where m is our gradient and c is our y-intercept. So I can say that 4y minus 3x equals 10. I can then add 3x to both sides, so I get 4y equals 3x plus 10. And then I can divide both sides by 4, so I get y equals 3/4 of x plus 10 over 4. So from this equation I can see that the gradient of L1 is equal to 3/4. Now in L2 instead of giving us the equation, they've given us 2 points that pass through the line. So what we can do is we can work out the equation from these 2 points. So what I'm going to do is I'm going to draw a quick little sketch of where these points will roughly be. So we're going to have 5, -1, which would be somewhere here. We're going to have -1, 8, which would be somewhere up here. We can then draw a straight line connecting the 2 points, and then we can draw dotted lines going between the 2 points to work out the gradient. So the gradient, remember, is the change in y divided by the change in x. So we need to work out how many units do I need to go down parallel to the y-axis, and then how many units do I need to go across parallel to the x-axis. So to get from 8 to -1, I'm going to go down -9. And then to go from -1 to 5, I'm going to go across 6. So I can say that the gradient of L2 is change in y, which is -9, divided by change in x, which is 6, and that simplifies to -3/2. Straight away, by comparing the 2 gradients, I can see that they are not parallel. If they were parallel, then they would have the same gradient. So we can say that L1 and L2 are not parallel. And then to work out whether they're perpendicular, we need to see whether one of the gradients of the lines is the negative reciprocal of the other gradient of the other line. So the way we can do that is if we multiply the 2 gradients together and we get an answer of -1, that shows that the 2 lines are perpendicular. So if we do 3/4 times -3/2, well, that gives us -9/8. Now -9/8 does not equal -1. So we can say that L1 and L2 are not perpendicular. And therefore, the lines L1 and L2 are neither parallel or perpendicular. This is due to the gradients not being the same value and the product of 2 gradients not being equal to -1. And that is question 4. Question 5 says a student's attempt to solve the equation 2 log to the base 2 of x minus log to the base 2 of root x equals 3 is shown below. Part A says identify 2 errors made by the student, giving a brief explanation of each. Okay, so the first error here is within the first couple of lines. And the issue is that the subtraction law cannot be used before dealing with the 2. So the first thing that we should do is, rather than having 2 log to the base 2 of x minus log to the base 2 of root x equals 3, rather than using this the subtraction law, we need to take the 2, we need to use the power law of log, so we need to bring the 2 up, so we get log to the base 2 of x squared minus log to the base 2 of root x, which is then equal to 3. So that's the first thing that they should have done. Now, simplifying it is okay, but again, they should have dealt with the 2 first. The power law looks okay, but if you look here, where they've used the definition of a log, They've said x equals 3 squared, which equals 9. Well, the general definition for a log is what we say is we have our log, we have our base, and then this value is our answer, and that's equal to our exponent. So what's happening is if we've got log to the base 2 of x, which equals 3, we obviously want to rewrite this as the base to the power of the exponent is then equal to our answer. Well, in this case, our base is 2 and our exponent is 3, so we're actually going to have 2 to the power of 3, which equals 8. It shouldn't be 3 to the power of 2. What they've done is they've taken the answer and they've raised it to the power of the base. That's not right. So we can say that the definition of a log is used incorrectly. Part B says we need to write out the correct solution. So okay, what we can do is we can use the power law, so we can bring the 2 up. So we've got log to the base 2 of x squared minus log to the base 2 of root x, which is equal to 3. Now we can use the subtraction law, where we get log to the base 2 of x squared divided by root x, and that equals 3. Well, remember, root x is the same as x to the power of a half. So what we're doing is we're doing x squared divided by x to the power of a half, which using our law of indices simplifies to x to the power of 3 over 2. So we get log to the base 2 of x to the power of 3 over 2, which equals 3. So now we can use our definition for a log, and we can say that x to the power of 3 over 2 equals 2 cubed. So we get x to the power of 3 over 2 equals 8. Then what I can do is I can work out x by taking the cube root of 8 and then squaring it. So the cube root of 8 is 2 and 2 squared is 4. So my final answer is therefore x equals 4. Question 6 shows a parabola. A company makes a particular type of children's toy. The annual profit made by the company is modeled by the equation P equals 100 minus 6.25 all multiplied by x minus 9 squared, where P is the profit measured in thousands of pounds and x is the selling price of the toy in pounds. The sketch of P against x is shown in figure 1. Using the model, explain why £15 is not a sensible selling price for the toy. Okay, so to work this out, part A is we can use this equation, P equals 100 minus 6.25 all multiplied by x minus 9 squared, and we can work out the profit by substituting in our selling price of £15. If you like, we've let x equal £15. So if we simplify this on our calculator, we get minus 125. And the question says, explain why £15 is not a sensible selling price for the toy. Well, we can say if the company sold the toy for £15, they would make a loss of £125. That's part A. Part B says, given that the company made an annual profit of more than £80,000, find according to the model the least possible selling price for the toy. Right, so what we can do is we can take our equation for the profit, make it greater than 80,000, and then we can solve the inequality to work out our minimum price of x. Now we've got to be a bit careful here because the question says that the profit is measured in thousands of pounds. So this 100 here isn't £100, it's £100,000. So that means that the profit, P, we're going to write as 80, not 80,000. So we can say that 100 minus 6.25 all multiplied by x minus 9 all squared is greater than 80. Okay, and now we can solve for x. So if I subtract 100 from both sides, I'm going to get minus 6.25 all multiplied by x minus 9 all squared is greater than minus 20. Now I'm going to need to divide both sides of my inequality by minus 6.25. So what's going to happen is when we divide inequalities by a negative number, we change the sign of the inequality. So we're going to have x minus 9 all squared is less than minus 20 over minus 6.25, which is 3.2. So now I can square root both sides, so I get x minus 9 is less than plus or minus the square root of 3.2. And I can add 9 to both sides, is less than plus or minus root 3.2 plus 9. So what this means is we're going to have an inequality of 9 minus root 3.2, which is less than x, which is less than 9 plus the square root of 3.2. So now the minimum value of x is going to be this value here, which, if we type that into our calculator, we get £7.21. So we can say the least possible selling price for the toy is £7.21. Question C says the company wishes to maximize its annual profit. State according to the model the maximum possible annual profit. Okay, so remember, X represents the selling price and P represents the profit. Now, if we have a look at this equation, you should be able to see that the X minus 9 all squared represents a translation of 9 units to the right. So our maximum, which is this point up here, has an X coordinate of 9. Now, our Y coordinate, which is going to be the value for our profit, is going to be when X is equal to 9. Well, when X is equal to 9, we get a profit of 100. But remember, the question says that the profit is measured in thousands of pounds. So we can say that the maximum profit, maximum annual profit, is equal to £100,000. And then the second part basically says what is the maximum selling price of the toy that maximizes the annual profit. Well, maximum selling price is £9 based on the maximum point from the equation and the graph. Question 7 says, in a triangle ABC, side AB has length 10 centimeters, side AC has length 5 centimeters, and angle BAC equals theta, where theta is measured in degrees. The area of the triangle ABC is 15 centimeters squared. Part A says find the two possible values of cos theta. So to work this out, if we draw the triangle ABC, which will look something like this, we know that AB has a length of 10 centimeters, and we know that AC has a length of 5 centimeters, and the angle BAC, which is this angle here, is theta, and we know that the area of ABC is equal to 15 centimeters squared. Now we also know that the area of a triangle is equal to a half AB sine C. So what we can do is we can say that a half times 5 times 10 times sine theta is equal to 15. Well, if I simplify the left-hand side, I'm going to get 25 sine theta is equal to 15. Divide both sides by 25, I get sine theta is equal to 15 over 25, which is the same as saying sine theta equals 3 over 5. So now what I can do is I could draw another triangle down here, and I could call this angle theta, and then because sine theta is opposite over hypotenuse, I could say that this is my opposite length of 3, this is my hypotenuse of 5, and then I can work out my adjacent side by using Pythagoras. So that's going to be the square root of 5 squared minus 3 squared, which is plus or minus 4. So if I put plus or minus 4 down here, that means cos theta could equal adjacent over hypotenuse, which is 4/5, or cos theta could equal minus 4 over 5. So that's part A. And then part B says, given that BC is the longest side of the triangle, find the exact length of BC. Well, if BC is the longest side of the triangle, that means that it's also going to have the longest angle, which is opposite the side length of BC. So what we can do is we can work out our values for theta by taking the inverse of cos of both sides. So we get the inverse of cos 4/5. Or remember, your calculator has to be in degrees, and that simplifies to 36.87 degrees to 2 decimal places. And then we've got theta equals the inverse of cosine of minus 4/5. And that simplifies to 143.13 degrees to 2 decimal places. So you should be able to see that theta equals minus 4/5 is the largest angle of theta. So because we've got an angle and we've got two other side lengths to this triangle, we can use the cosine rule. So the cosine rule states that a squared is equal to b squared plus c squared minus 2bc cos a. Now, if we say a squared is the length of BC, that means that our other two sides, B and C, are going to be the values of 10 and 5. So we're going to have 10 squared plus 5 squared minus 2 times 10 times 5. And then we need to multiply this by cos of the angle A. Now the angle A in the diagram is actually the angle theta. So if we replace cos theta with minus 4/5, we can just multiply this by minus 4/5. So we get a squared equals, simplify this on your calculator, you get a squared equals 205, and then if you take the square root of both sides, you're going to get a equals the square root of 205. Question 8 says a lorry is driven between London and Newcastle. In a simple model, the cost of the journey, £c, when the lorry is driven at a steady speed of v kilometers per hour, is c equals 1500 over v plus 2v over 11 plus 60. Part A says find, according to this model, the value of v that minimizes the cost of the journey. So that's the first part A. So what's happening here is we've modelled this situation with this equation, and we've got to find a value of v which minimises c. So what we're technically saying is we actually need to find the minimum point of this equation. Now, the minimum point is a stationary point of the function, and we can work that out by taking the derivative of this equation and then making the derivative of the function equal to 0 and then solving for v. So that's what we're going to do. But first I'm going to rewrite c. So we're going to get c equals 1500 v to the power of minus 1 plus 2 over 11v plus 60. Now, when we differentiate this, we've got the variables c and v, so we're going to do dc by dv. So remember, when we differentiate, we take the power, multiply it down by our coefficient, and then subtract 1 from the power. So we're going to get minus 1500 v to the power minus 2 plus 2 over 11. Now we say let dc by dv equal 0. So we get minus 1500 v to the power minus 2 plus 2 over 11 equals 0. I can then add 1500 v to the power minus 2 to both sides. So I get 2 over 11 equals 1500 v to the power minus 2. Now I'm going to rewrite that as 2 over 11 equals 1500 over v squared. And now what I can do is I can multiply both sides of the equation by v squared. So I get 2 over 11 v squared equals 1500. And then I can multiply both sides of the equation by 11 and then divide by 2. So I'll get 1500 times 11, divide that by 2, gives me v squared equals 8,250. And then I can take the square root of both sides, so I get v equals plus or minus square root of 8,250. And that simplifies to plus or minus 90.8. And the units is in kilometers per hour. So we put kilometers per hour. So in this case, the velocity is going to be positive. So we can say that v is equal to 90.8 kilometers per hour. So that's the first part. And the second part says, find the minimum cost of the journey. What we're doing is we're taking this equation, we've worked out one of our values for the minimum point, now we need to work out the other value, which is the cost. This is our y value, if you like. So what we can do is we can substitute the square root of 8,250 into c. So I get c equals 1500 over square root of 8,250 plus 2 over 11 times the square root of 8,250 plus 60, and then I can work out what value I get for c. And I've used v as the square root of 8,250 because I want my answer to be as exact as possible. So I end up getting a value for c of 93.0 to 3 significant figures, so that's 93 pounds. Part B says, prove by using the second derivative of dc by dv that the cost is minimized at the speed found in part AI. So what we can do here is we can take the second derivative of the function, and then if our value is greater than 0, we've shown that we've got a minimum point. So first, if I rewrite dc by dv, which was minus 1500 v to the power minus 2 plus 2 over 11. Well, we can write the second derivative like this. And if we multiply down by the power and then minus 1 from the power, we're going to get 3000 v to the power minus 3. And then that constant of 2/11 is going to disappear. Now we've got the second derivative is equal to 3000 over v cubed. Well, v was 90.8 kilometers per hour. So what we can do is we can enter that into our second derivative. So I'm going to use the exact value, which is the square root of 8,250, so 8250, all cubed. And if we get a value greater than 0, the stationary point is a minimum point. So it is greater than 0, only very slightly. It comes out as 4 times 10 to the minus 3, but it is still greater than 0. So we can say, therefore, second derivative represents the minimum cost. So question 9 says the function g of x equals 4x cubed minus 12x squared minus 15x plus 50. Part A says use the factor theorem to show that x plus 2 is a factor of g of x. Okay, so if we write down our function g of x equals 4x cubed minus 12x squared minus 15x plus 50. We're going to test whether x plus 2 is a factor. If x plus 2 is a factor, then we can say, what we can do is we can substitute a value of x as minus 2. So we can say g of minus 2 is equal to 4 multiplied by minus 2 cubed minus 12 all multiplied by minus 2 squared minus 15 multiplied by minus 2 plus 50. If this result simplifies to 0, then we can say that x plus 2 is a factor. So if you work that out on your calculator, we get an answer of 0. So therefore, x plus 2 is a factor of g of x. Now, part B says, hence show that g of x can be written in the form g of x equals x plus 2 multiplied by ax plus b all squared, where a and b are integers to be found. X plus 2 is a linear factor, and the function g of x is a cubic polynomial. So what we can do is we can divide x plus 2 into the function g of x to get a quadratic factor, and then we can see what the values of a and b are from that factor. So to find the quadratic factor, I'm going to use polynomial division. So I'm going to work out how many times x plus 2 goes into 4x cubed minus 12x squared minus 15x plus 50. So the first thing I do is 4x cubed divided by x, which is 4x squared. And 4x squared times x is 4x cubed, and then 4x squared times 2 is plus 8x squared. I can subtract those two results, so I get 0, and then I get minus 20x squared. Then I can bring down the minus 15x and the plus 50. And I can divide the minus 20x squared by the x, so I get minus 20x. And I can multiply the minus 20x by the x, so I get minus 20x squared, and the minus 20x by the 2, so I get minus 40x. Subtract these results, I get 0, and then I get plus 25x plus 50. And then I can divide the 25x by the x, so I get plus 25, multiply the 25 by the x, so we get 25x, then multiply 25 by the 2, so we get plus 50. Subtract those two results, and I am left with nothing, so my remainder is 0. So I have a quadratic factor with no remainder, which is 4x squared minus 20x plus 25. So I now need to work out the factors of this quadratic equation. So what I'm going to do is I'm going to have two brackets which include 2x. Now I'm going to need to try and find two factors which multiply together to give me 25. Well, they are going to have to both be minus 5. So if I expand this and get the quadratic, 4x squared minus 20x plus 25, then I factorized it correctly. So we'll have 4x squared minus 10x plus 25, which simplifies to that quadratic. So what that means is my quadratic factor has integer values of a as 2 and b as minus 5. So I can say a is 2 and b is minus 5. Okay, and then part C says figure 2 shows a sketch of part of the curve with equation y equals g of x. Use your answer to part B and the sketch to deduce the values of x for which g of x is less than or equal to 0. Right, so we know where our graph now crosses the x-axis. It's at x equals minus 2 or x equals 5 over 2, which is 2.5. But what we need to do in part I is see what values of x are less than or equal to 0.
So the first part is basically saying what values of x cross the x-axis or are below the x-axis.
Well, if we use a graph, this point is x equals minus 2, and this point is x equals 2.5. Well, x equals 2.5 is our minimum point, which is a point where the graph crosses the x-axis. So if I just get rid of this, we can say that x is equal to 2.5, and then our other values of x is when x is below the x-axis or it's on the x-axis. Well, that means that x is going to be less than or equal to minus 2. So that's the first part. The second part says work out the values of g2 of x. Well, all we're basically saying is rather than having x equals 2.5 and x equals minus 2, we're saying that 2x equals 2.5 and 2x equals minus 2. So we just divide both sides by 2, so we get x equals 1.25 and x equals minus 1. Question 10. Prove from first principles that the derivative of x cubed is 3x squared. Okay, so what I'm going to do is I'm going to draw the graph of x cubed, which looks something like this. And if we plot 2 points on this graph, we can have the point P1 here, and up here we'll have the point P2. Now P1 is going to have an x coordinate of x, and it will have a y coordinate of function x. And then let's say P2 has an x value of x plus h, and it has a y value of function x plus h. Okay, and then what we can say is as P1 gets closer to P2, our value of h tends to 0. And the point of this is so that we can represent an equation for any tangent to the curve. So we can represent that as a limit. So what we can say is as P1 gets closer to P2, h will tend to 0, and they will almost touch each other. They won't touch each other, but they'll be very close. Because remember, h doesn't equal 0, it tends to 0. So what's going to happen is when P1 gets closer to P2, the points are going to tend to a single tangent. And the gradient of that tangent, which we can represent, well, we can say that function x equals x cubed, so the derivative of function x is equal to the limit as h tends to 0, and then we can just represent the derivative by the gradient function. So that is our change in y values divided by our change in x values, and this is the general formula for proving differentiation from first principles. And that is all over h. So now what we can do is we need to rewrite function x plus h and function x in terms of x cubed. So we know function x is x cubed, but function x plus h is going to be equal to x plus h all cubed. Now we can expand this out using binomial expansion. So I can say that x plus h all raised to the power 3 is equivalent to 3 choose 0 of x cubed, then h to the power 0, plus 3 choose 1 multiplied by x squared, and h to the power 1 plus 3 choose 2 multiplied by x to the power 1 multiplied by h squared, plus 3 choose 3 multiplied by x to the 0 multiplied by h cubed. So now, if we simplify this, 3 choose 0 is 1, h to the power 0 is 1, so we're just going to get x cubed, plus 3 choose 1, which is 3, so that's going to be 3x squared h, and 3 choose 2. 3 choose 2 is just 3, and then we've got x h squared, then 3 choose 3 is 1, x to the power of 0 is 1, so that's going to be plus h cubed. Okay, so that's what x plus h all to the power of 3 expands to. So now we can use our limit, so we can say f dash x equals the limit as h tends to 0 of x cubed plus 3x squared h plus 3x h squared plus h cubed, then minus function x, which is just x cubed, and then this is all going to be divided by h. So if we simplify this limit, the x cubes cancel out and we're left with 3x squared h plus 3x h squared plus h cubed all over h. Then we can divide through by h. So this is going to become 3x squared plus 3xh plus h squared. So now we can evaluate the limit. So what's going to happen is, as p1 gets closer to p2, the value of h is going to get closer and closer to 0. It's going to tend to 0. So what that means is, you could say down here, as h tends to 0, 3xh plus h squared will also tend to 0 because they contain values of h. And of course the whole limit, 3x squared plus 3xh plus h squared will tend to 3x squared because the value of 3xh will disappear and the value of h squared will disappear. So therefore we can say that function x, which is x cubed, when we differentiate it, we get 3x squared. That is question 10. Question 11, part A says find the first 3 terms in ascending powers of x of the binomial expansion of 2 minus x over 16 all raised to the power of 9, giving each term in its simplest form. Okay, so we need to use the formula for binomial expansion, which is in your formula book. So what we will do is, so if we use the formula, the first term is going to be 9 choose 0 multiplied by the first term raised to the power of 9 multiplied by the second term, which is minus x over 16 raised to the power of 0. And then we can add 9 choose 1. We can subtract 1 from the power from the first term, so that's going to be 2 to the power of 8. And then we can add 1 to the second term. So we get minus x over 16. And then we can repeat this formula for the third term. So it simplifies to that. So now 9 choose 0 is 1, then we've got 2 to the power of 9, which if I type that in on my calculator is 512, minus x all over 16 raised to the power of 0 is going to be 1, so that simplifies to 512. For the second term, we're going to have 2 to the power of 8, which is 256, divided by 16, which is 16, then times by 9, which is 144, then multiplied by minus x. So we're going to get minus 144x. And then the third term, 9 choose 2 is 36. And then 36 times 2 to the power of 7. Then multiply by minus 1/16 squared gives us 18. And then we've got x squared. And that is the first 3 terms for that first expansion. Now we're then told that function x equals a plus bx, all multiplied by 2 minus x over 16, all raised to the power of 9, where a and b are constants, given that the first 2 terms in ascending powers of x in the series expansion of function x are 128 and 36x. Part B says find the value of a. Okay, so what I'm going to do is, if we rewrite this, if we write out this function, so we've got function x equals a plus bx multiplied by 2 minus x over 16 raised to the power 9. Well, we're told what the first two terms of this function are. The first term is 128 and the second term is 36x. So what I can do is, in the first part, I worked out my first three terms for the expansion of 2 minus x over 16 all raised to the power 9. So what I can do is I can replace that binomial with what I worked out in the first part. So my function is going to equal a plus bx all multiplied by 512 minus 144x plus 18x squared. Now what I'm going to do is I'm going to expand this bracket out. So I'll multiply a by 512, so I get 512a. I get minus 144ax, then plus 18ax squared, and plus 512bx, and we get minus 144bx squared, and then the last one is plus 18bx cubed. Now, my first two terms are 128 and 36. Well, 128 is just a constant, and then 36 is a coefficient of x. So all I need to do is I need to collect the terms which are constants and the terms that are coefficients of x. So I can ignore any coefficients of x squared or x cubed. So if we just say function x is equal to 512a minus 144ax plus 512bx, then that's all we need to worry about. And then what I'm going to do is, for part B, I need to work out the value of a. Okay, so if I write the function underneath it, where this first term is 128, can you see that 512a will equal 128 if I equate coefficients? So now I've got an equation where I can solve for a, so I divide both sides by 512, and if I simplify this on my calculator, I get a quarter. So a is a quarter. Now we can do a similar thing for question C, where we have to find the value of b. So what we can do here is, if we simplify the coefficients of x, so we got function x equals 512a. Now, and if I factorize out the x, I'll get plus x minus 144a plus 512b. Now, this bracket here is my coefficient of x. So what I can do is I can equate coefficients, because I know that for the function, my coefficient of x is 36. So what I can do is I can do minus 144a plus 512b is equal to 36. Now, I've worked out my value of a in part B, which was a quarter. So if we do minus 144 multiplied by a quarter plus 512b, and that's equal to 36. So if I do 144 divided by 4, I get minus 36 plus 512b equals 36. I can then add 36 to both sides, so I get 512b equals 72. And then I can divide both sides of my equation by 512. So 72 divided by 512 is 9 over 64. So I've got my two values for a and b, and that is everything that question 11 asked me to do. Question 12, part A, says show that the equation 4 cos theta minus 1 equals 2 sine theta tan theta, and that this can be written in the form 6 cos squared theta minus cos theta minus 2 equals 0. So if we write out the equation, so it's 4 cos theta minus 1 equals 2 sine theta tan theta. So we can use the trig identity. Tan theta equals sine theta over cos theta. So if I replace tan theta with sine theta over cos theta, I'm going to get 4 cos theta minus 1 equals 2 sine theta then multiply by sine theta over cos theta. Now, if we concentrate on the right-hand side, that's going to simplify to 4 cos theta minus 1 equals 2. Then the 2 sine thetas is going to give me sine squared theta all over cos theta. Now, I can multiply both sides of my equation by cos theta. So I'm going to get cos theta multiplied by 4 cos theta minus 1, and that equals 2 sine squared theta. And if we expand the left-hand side, we're going to get 4 cos squared theta minus cos theta equals 2 sine squared theta. Now, the form that they've written the equation in is all in terms of cos theta. On the right-hand side, we can use the trig identity, sine squared theta plus cos squared theta equals 1, and rearrange sine squared theta in terms of cos squared theta. So we get sine squared theta equals 1 minus cos squared theta. Okay, so if we replace sine squared theta with 1 minus cos squared theta, we're going to get 4 cos squared theta minus cos theta equals 2, all multiplied by 1 minus cos squared theta. If we simplify this, we get 4 cos squared theta minus cos theta equals 2 minus 2 cos squared theta. And then what we can do is we can move everything over to the left hand side because we want the equation to equal 0. So if we add 2 cos squared theta to both sides, we're going to get 6 cos squared theta, and then we're going to have minus cos theta, and then subtract 2 from both sides is going to be minus 2 equals 0. And as you can see, that is the form that the equation has been written in. Now, in part B says, hence solve for x between 0 and 90 degrees, 4 cos 3x minus 1 equals 2 sine 3x tan 3x. Giving your answers where appropriate to one decimal place, solutions based entirely on graphical or numerical methods are not acceptable. Okay, so the trick with this question is that you should be able to see that there's some relationship between this equation and the equation that we had in part A. And the difference is that theta has been replaced with 3x. Okay, now you're probably thinking, how can we solve an equation like this? In part A, we had to rewrite the equation in terms of theta into this quadratic, 6 cos squared theta minus cos theta minus 2 equals 0. So what that means is, if these two equations are the same, we've just replaced theta with 3x, then we can use the equation in its rewritten form and then replace theta with 3x. So what we're going to have is part B, we can use 6 cos squared theta minus 2 equals 0, and we can let theta equal 3x. So we could write this as 6 cos squared 3x minus cos 3x minus 2 equals 0. Now what I'm going to do is I'm going to say let some variable, let's call it y, equal cos 3x. Okay, and you'll see why I've done this, because it will make it a bit easier to solve. So now I can rewrite my quadratic as 6y squared minus y minus 2 equals 0. Okay, so if I factorize this quadratic, I know it's going to have factors of 2 and 1, and in our bracket we'll have 3y and 2y. Now, if I make this minus 2 and this plus 1, you should be able to see if I expand it, I'm going to get 6y squared plus 3y minus 4y, which is minus y, and then minus 2 times 1, which is minus 2. So if I solve this, I'm going to get y equals 2/3, or y equals minus a half. Okay, but remember, cos 3x is equal to y, so I can say cos 3x equals 2/3, or cos 3x equals minus a half. So if we look at cos 3x equals 2/3, and we work out the inverse of cos, which is going to be 3x equals the inverse of cos of 2/3. So if I work that out on my calculator now, our angle is going to have to be in degrees, and we're looking for solutions between 0 and 90, so make sure your calculator is in degrees. So the inverse of cos of 2/3. Right, so I've got 48.1896851. So what I'm going to do, is I'm going to draw my cast diagram, which looks something like this. So we've got CAST. We've got an angle just over 48 degrees. So that will look something like this. We'll call it 48.19 degrees. I'm looking for another solution for cos, so that's going to be in the fourth quadrant. So what I'm going to have to do is, if I go around this circle, what I'm actually doing is I'm doing 360 degrees minus the angle of 48.19. So if we do 360 minus answer, we get 311.81. So I can say 3x is equal to 311.81031149 occurring. Then what I can do is I can divide by 3 on my calculator. Now my answer has to be to 1 decimal place. So when I divide by 3, I get 103.9. Now my value of x had to be within the region of 0 and 90, so I can't actually include this solution as my answer. So I'm just going to put not a valid solution due to being outside of range. So what that means is my original answer is the only solution to cos 3x equals 2/3 within the range of 0 to 90. That to 1 decimal place is going to be x equals 48.2 degrees. Now, and if we look at the second term, cos 3x equals minus a half. If I work out the inverse of cos, I'm going to have 3x equals inverse of cos of minus a half. And if I work that out on my calculator, I get 120 degrees. Now, and if I draw that on my car circle, CAST, now 120 is going to be somewhere over here. That's this angle here, and that's 120. But it can also be in this range here. So that's 120. So if I did 360 minus 120, I get 240. So we can also have 3x equals 240. Now, and if I divide both sides of this equation by 3, I'm going to get x equals 80. And if I divide both sides of this equation by 3, I'm going to get x equals 40. And they are my two solutions, which were in the range of 0 to 90. Now, this was 3x equals 48.2. So if we divide that by 3, we're going to get x equals 16.1 to 1 decimal place. So that means our values of x are 16.1 degrees, 40 degrees, and 80 degrees. And that's question 12. Question 13, the value of a rare painting is modelled by the equation V equals PQ to the power T, where P and Q are constants and T is the number of years since the value of the painting was first recorded on the 1st of January 1980. The line L shown in figure 3 illustrates the linear relationship between T and log base to the 10 of V since 1st of January 1980. The equation of line L is log to the base 10 of V equals 0.05t plus 4.8. Part A says find to 4 significant figures the value of P and the value of Q. Okay, so we're told here that the situation is modelled with the equation V equals PQ to the power T. Okay, so let's use that as our starting point. V equals PQ to the power T. we want to try and rewrite this equation so it looks something like this. Log to the base 10 of v equals 0.05t plus 4.8. Okay, so obviously we've got this log to the base 10 of v, which represents our y-axis. So what we're going to have to do is we're going to have to take log to the base 10 of both sides of this equation. So we're going to have log to the base 10 of v equals log to the base 10 of pqt. Now, you should be able to see on the right-hand side that we've got a log which includes the product of two constants. And what we can do is we can use log laws to change this product so that we have log to the base 10 of p plus log to the base 10 of qt. So if I write that, we get log to the base 10 of v equals log to the base 10 of p plus log base to the 10 of q to the power t. That's one of our log laws. Then if we use another log law, which is where we have powers, where we can bring the power down so that it's in front of the logarithm. Here, log to the base 10 of q to the power of t, we can rewrite as t multiplied by log to the base 10 of q. And then I can just add this information on in front of it. So now what you should be able to see is this equation looks very similar to the equation of the line log to the base 10 of v equals 0.05t plus 4.8, and I'm going to write it underneath so that we can sort of compare both of the terms. So log to the base 10 of v equals, now this is going to be 4.8 plus t multiplied by 0.05. Okay, well what we can do is we can compare terms. So we can say that basically both of these equations are equal to each other, and we're basically just comparing coefficients. So the two constants we can compare is log to the base 10 of p, which is equal to 4.8, and then we can compare the coefficients of t, which is log to the base 10 of q, which is equal to 0.05. Now I can just convert these logarithms into their exponential form. So I'm going to get p equals 10 to the power 4.8. If I solve that on my calculator, I get 63,095.73445. Now, I want to write that to 4 decimal places. So that's going to be 63,100. So the 5 at the end is going to round up the 9 to 100. So that's P, and then Q is going to be 10 to the power of 0.05. Do that on my calculator, I get 1.122 to 4 significant figures. So I'll just write 4 significant figures. And they are my values of P and Q. Now, part B says, with reference to the model, interpret the value of the constant p and the value of the constant q. So what that basically means is we need to explain what the value of p and q mean in context. So what you should be able to see is that this equation, log to the base 10 of v equals 0.05t plus 4.8, well, this represents the equation of a straight line. And of course we know that the general form for the equation of a straight line is y equals mx plus c. So c, in this case, which is our y-intercept, is 4.8, and m, which is our gradient, is 0.05. So that's basically what I need to explain. I basically need to refer these figures back to the context of the question. So if c is the y-intercept, which if we look on the graph is here, the value of p is going to represent the cost of the painting at the date in which it was first recorded, so the 1st of January 1980. So we can say that p represents the value of the painting on 1st of January 1980. Now part 2, we need to reference what q represents. Now the constant q in this case is the gradient. Now the gradient represents the value at which a function increases or decreases. So now we can see that this line is increasing. So what that means is the constant q represents the rate at which the value of the painting increases each year. So we can say q represents the rate at which the value of the painting increases each year. Now part C says find the value of the painting as predicted by the model on the 1st of January 2010, giving your answer to the nearest £100,000. Okay, so we can use either equations. We can use the exponential equation, or we can use the equation in log form. I think I'm going to use the exponential equation as it's a lot easier to evaluate. So that is v equals pq to the power of t. And then we've got our values of p and q. P is 63,100 and q is 1.122. Now t represents time, the number of years that have gone past in which we value the painting at a particular point. So if we need to value the painting on the 1st of January 2010 and it was first valued on the 1st of January 1980, that means 30 years have passed. So t is going to equal 30. So I can raise this to the power of 30. Now, and if I evaluate this using my calculator, now I get 1,994,412 pounds and then 865p. But the question said, give your answer to the nearest £100,000. So the nearest £100,000, I've got 994,000. So if I'm going to round that up to the nearest 100,000, that's going to bring the value up to 2 million. So that is our answer for part C, 2 million. Question 14 says the circle C has equation x squared plus y squared minus 6x plus 10y plus 9 equals 0. Part A says find the coordinates of the centre of C and the radius of C. So what we need to do is we need to rewrite this equation in the form of x minus a all squared plus y minus b all squared, and that's going to equal the radius squared. The equation at the moment is in its fully expanded Cartesian form. So what I can do is I can collect the x terms, collect the y terms, and complete the square. If I rewrite this as x squared minus 6x plus y squared plus 10y plus 9 equals 0, if I do completing the square for the x terms, I'm going to half the coefficient, which is going to be x minus 3 all squared. Then I'm going to square the minus 3 and subtract it, so that's going to be minus 9. And then I can complete the square on the y term, so I can half the coefficient of 10y, so that's going to be y plus 5 all squared. Square the 5 and subtract it, so it's going to be minus 25. And I can add the 9 on the end, and that's going to equal 0. So if I simplify this, I'm going to get x minus 3 squared plus y plus 5 all squared. Now minus 25 minus 9 is going to be minus 34, and minus 34 plus 9 brings us back to minus 25. So we can move the minus 25 over to the right hand side, so this is equal to 25. Now part I says work out the centre, so you should be able to see that the centre is going to have an x coordinate of 3 and the y coordinate is going to be minus 5. And the second part for the radius, well, if r squared equals 25, then we can square both sides and say that r must equal 5. Now, strictly it would be plus or minus 5, but because we're talking about the radius, which is a magnitude, can't have a negative value for the radius. So that is part A. And then it says the line with equation y equals kx where k is a constant, cut C at two distinct points. Find the range of values for k. Okay, so first what I'm going to do is I'm going to draw a diagram. And we know our circle has centre 3 minus 5. So let's say that's around here. And its radius is 5. So if I draw a circle, and let's say it looks something like this. So I'm going to change the centre. Just put it there slightly. If we have an equation y equals kx, that is going to intersect this circle at two particular points, well, we know that y equals kx is a straight line that passes through the origin. So if I was going to draw a straight line passing through the origin, now on this line, it can move up, and of course it can move down, and k is all dependent on the gradient. But of course the circle is only in the fourth quadrant of my graph. So what that means is k will surely have to be negative in order for it to intersect at least 2 points on the circle. You should be able to see that. So what I can say is, well, k is never going to be positive, because if it's positive, can you see it's never actually going to touch the circle. So if I get rid of this, I can straight away say that k will have to be negative, so it has to be less than 0. Now k is also going to have to satisfy other values, and we can test what those other values are by using something called the discriminant. Now what we're going to have to do first is we're going to have to imagine that we're solving this simultaneously, so we're working out what our solutions are to x and y. So what I can do is I can substitute y equals kx into the equation of my circle. What I'm going to do is I'm going to have x squared, and I'm going to replace y with kx, so it's going to be plus kx all squared minus 6x plus 10 multiplied by kx plus 9 equals 0. Now, and if I simplify this, I'm going to get x squared plus k squared x squared minus 6x plus 10kx plus 9 equals 0. I can then work out my coefficients for x squared and x by factorising out x squared. So I get k squared plus 1. And then here I can factorise out x, so I get 10k minus 6, and then plus 9 equals 0. So now I've got my quadratic equation, which I now need to find my solutions of x. But rather than solving it, what we're going to do is we're going to use the discriminant. The discriminant is b squared minus 4ac. Now there's 3 different cases for the discriminant. The one we're going to test is whether b squared minus 4ac is greater than 0. And if that value is greater than 0, what we say is that the equation has 2 solutions. And that's what we're told in the question. That's why we're going to test for it, because we know that the line y equals kx passes through 2 points. What I can do is I can work out my values for a, b and c. A is going to be k squared plus 1. B is going to be 10k minus 6. And c is going to be 9. So if I substitute these into my discriminant, I'm going to get 10k minus 6 all squared minus 4 times k squared plus 1 all multiplied by 9, greater than 0. I can then expand out this bracket, and then I can simplify this, so I'm going to get minus 36k squared minus 36 is greater than 0. And then expand this bracket, we're going to get 100k squared minus 60k minus 60k plus 36 minus 36k squared minus 36 is greater than 0. We simplify this, we get 100k squared minus 120k minus 36k squared is greater than 0. 100k squared minus 36k squared is 64k squared. And that's minus 120k, and that's greater than 0. So what I can do is I can factorize out k, and I'm then going to get 64k minus 120 is greater than 0. Now, we've already shown that k has to be less than 0. I've shown that on the graph. But if we show that 64k minus 120 is greater than 0, then we're going to get 64k is greater than 120. And then I can divide both sides of the equation by 64, so I get k is greater than 15 over 8. So we can say, therefore, in order for the line y equals kx to intersect C at two distinct points, k needs to be less than 0 and k needs to be greater than 15 over 8. And that's question 14. Question 15. Figure 4 shows a sketch of part of the curve C with equation y equals 32 over x squared plus 3x minus 8, where x is greater than 0. The point P, 4, 6 lies on C. The line L is the normal to C at the point P. The region R, shown shaded in figure 4, is bounded by the line L, the curve C, the line with equation x equals 2, and the x-axis. Show that the area of R is 46, and then solutions based entirely on graphical or numerical methods are not acceptable. There's quite a lot of information here that we need to try and break down. So we're trying to find out what the area of R is. What I'm going to do is I'm going to split this area into two separate bits, drawing a line from point P to the x-axis. So I'm going to have two different areas here, and what we can do is we can work out these areas separately. So area 1, we can just use the equation of the curve and integrate it between point P, which is x equals 4, and then the line x equals 2. So we can find out what the area of 1 is. Area 2 is a bit more trickier. We've got this line L, which intersects both the x-axis and the curve C. Now the line L is also a normal to the curve C. Now what we'll be able to do is we'll be able to work out the gradient of the normal at the point P, and then we can work out where the line intersects the x-axis by making y equal to 0. Now we don't even know what the equation the line L is, so I'm going to work that out first. So to work out the equation of line L, we're going to need to differentiate our function to work out what the gradient is, and then we can work out what the negative reciprocal of the gradient is in order to work out what the gradient of the normal is. If I write the function as y equals 32 x to the power minus 2 plus 3x minus 8, then I can differentiate the function, multiply minus 2 by 32, so we get minus 64, and then I can minus 1 from power, so we get minus 3, and we get plus 3. This gradient function is going to be the gradient of the tangent at the point P. Now the point P has x coordinate of 4. So it's going to be dy by dx equals minus 64 multiplied by 4 to the power minus 3 plus 3. So if you work that out on your calculator, we get an answer of 2. So that's the gradient of the tangent at P. So the gradient of the normal at P is going to be the negative reciprocal, which is going to be minus 1/2. Okay, so now what I can do is I can work out the equation of the line by using y minus y1 equals m bracket x minus x1. Obviously this is going to be at P, which is coordinates 4, 6. So we can say y minus 6 equals minus a half multiplied by x minus 4. I can then multiply the equation through by 2, so I get 2y minus 12 equals minus 1 multiplied by x minus 4. And then I can simplify this by doing 2y minus 12 equals minus x plus 4. I'm going to rewrite this as x plus 2y minus 16 equals 0. So what I need to work out is what is the value of x when the line L crosses the x-axis? Well, that's going to be when y is equal to 0. So when y is equal to 0, I'll get x minus 16 equals 0, so that just comes to x equals 16. So now I've got my value of x, which is 16 here, I can now work out what the area of the second region is. Because this is x equals 4, so this distance along here is going to be 16 minus 4, which is 12. And then, of course, point P is 6 units parallel to the y-axis, so this is 6 units high. So now we've just got a right-angled triangle with a base of 12 and a height of 6. So if I say region 2 is a half multiplied by a base of 12 multiplied by a height of 6. I'm going to get half of 12, which is 6. 6 times 6 is 36 units squared. Now, region 1 we can work out by integrating the function between x equals 2 and x equals 4. So region 1, we're going to integrate 32x to the minus 2 plus 3x minus 8 with respect to x, and that's going to be between 4 and 2. So what I can do is I can add 1 to the power, divide by the new power, so I'm going to get minus 32x to the power of minus 1, and plus 3x squared all over 2 minus 8x, and I've got my limits of 4 and 2. I can then substitute these points in, so I get minus 32 multiplied by 4 to the power minus 1 plus 3 over 2 multiplied by 4 squared minus 8 multiplied by 4. I'm just going to move this across over here so we've got a bit more space, and I can subtract minus 32 multiplied by 2 to the power minus 1 plus 3 over 2 multiplied by 2 squared minus 8 multiplied by 2. And now I can evaluate these using my calculator. So I get minus 16 here, and then we're going to have minus 32, 2 to the power minus 1 plus 3 over 2 multiplied by 2 squared minus 8 times 2. Now I get minus 26 here. So this becomes minus 16 plus 26, which is 10 units squared. So region 2 was 36 units squared, region 1 is 10 units squared. So therefore I can say, therefore the total region R equals 10 plus 36, which equals 46 units squared. And that is what we had to show. So that is the final question, question 15. Thanks for watching the video, guys. Don't forget to subscribe to the channel if you haven't done so already. Make sure to also check out our website at www.easymaths.com, where you can find both the exam and mark scheme to this paper.